It's a vector is an object that has both a magnitude and direction, right? Sorry, and the matrices is used. Okay, I had a reason why I didn't want to use this. All right. So vectors, right? So those are very commonly. A vector is an object that has both a magnitude and direction. What is a magnitude? Anybody remember? What does magnitude mean? And we're revising here, so you should have your books with you. What does magnitude mean? Anybody? What does magnitude mean in terms of
It means size.
Size.
size, right? It has a size. And when it means size, is a what? Really a length, right? So magnitude really means the length of the line or the length of the vector. And what does this direction mean now? The direction is really x and y value in the matrix form. And from knowledge on how a graph is drawn, right? If we have a point here, if you have a point here, and you move the point up, what will happen to the y values? The y values increase, right? Or will be positive. And if you move the point downward on a graph, the y values become negative or minus, right? Decrease. If you move right on the graph, the x values increase or are positive. And if you move left on the graph, the x values decrease or are negative. right? So a vector basically represents the direction a line is moved. So if we say this is A and this is B, we move to the right. So the vector itself would have a positive x value, and we went up, so it will have a positive y value. That makes sense? Or no?
Repeat what you said.
All right, let me try that again. All right, it's in red. If this is a point here, right, E, and this is the point B, and the vector represents going from point A to point B, right? The vector, the direction of the vector, because we went to the right and then up, will have a positive x value and a positive y value. If the vector had gone from A in this direction, let's call it C, right? We went to the right, so we have a positive x value, but we went downward, right? So therefore the y will be negative. We went from A in this direction to a point D. We went to the left, and then we went
Would
downward.
be negative x and negative y.
Very good. Very good. Very good. And what other color we could use? By dark blue. Right. And if we went in this direction to point E,
So negative x and positive.
so yes, you'll have a negative x and a positive y because you went left and then up, right? So I'm gonna give you all some time to take this down. Um,
Say you recording this, right? And you go and post it up on your page, right?
yeah, yeah. I,
Alright, good.
I using the wrong thing this morning. I should have used the regular paint. So I want you all, in fact, you know what? If you're not gonna write it right away and you're gonna just watch,
I'm watching and I'm writing it until
right?
you post it up.
And yeah, when I post it up, that make more sense. You know what? I'm gonna exit the screen share. You see, I want the notes. That's the problem. All right, let me see if I can save this here. All right. I'm gonna just try to open that file that I had there just now, right? I want to be able to edit it. Come on, computer, you can do this. Nice. Nice. All right. So we have everything in one spot. Good. Now, in vectors, right? If we multiply in fact, no, if we add in vectors, addition of vectors, And we represent a vector with a little arrow on top, right? Right? Now, if we were to watch this, right, vector AB equal 3, 5, and the vector BC equal to 4, 3. If you had to represent this on a graph, just by sketching it, you know, this will be X, this will be Y, right? If we call this point A, right, and we go into the point B, and there's a positive 3 and a positive Y, what direction would I go? I'd go to the right, and then up 3 spaces, right? 5 spaces, right? So B will be here. And then from B to C now is positive 4, positive 3. So the X will represent the 4, so we go across 4, and then we come up 3. Right, so C. So you go AB to BC. Now what it is they're asking us to find by adding is the vector from A to C. Right? This would give us AC. This rule is also called the triangle law for vectors in addition. Right? But we will go through that after. So what it is really doing for addition, right? We add in like if it's matrices, the top or the rows will add the rows, right? So 3 would add 4, 5 would add 3 here. And we will get 7 over 8, right? And what is the resultant vector? The resultant vector, you remove the letters in the middle to get A, C. That hard?
No.
You need to explain it again.
Yeah. It easy, but explain it one more time.
So I want to draw over the diagram, right? And this is why we do it, right? So we start at a point here, E. The vector AB represents 3, 5. So I'm going across 3 and coming up 5. Right? So that is B. That is the vector from A to B. Now from B to C, we're going across 4. 1, 2, 3, 4. And then we're going up 3. 1, 2, 3. Right? So that's C. So the vector from B to C. Now when you add vectors, right, the answer we get is called the resultant vector. Right? So basically what they're asking us to find is the vector from A to C. Right? This is called a resultant vector. Right? So if this is 3, 5, and here's 4, 3, the resultant vector would be AB plus BC. Right? And I'll write it here already, but let me write it again. AB from A to B is 3 over 5. And from B to C is 4 over 3. So we just adding them in like matrices method. 3 will add to 4, and 5 will add to the bottom 3. So we get 7 over 8. So the vector from A to C, right, will be 7 to the right and 8 going up. And if we check the dashes, we'll have 1, 2, 3, 4, 5, 6, 7, right? So 7 is correct. And going up, we go 1, 2, 3, 4, 5, and then 1, 2, 3. So that's 8. So vectors is very simple as long as you could see it in the graph space. That's the easiest way to put it. Right? So if you could see it like a graph. Now, from the note, if a vector changes direction, we multiply the vector by -1. Right? So that's like scaling a vector. In matrices, right? If they tell us to simplify this, 3 by a matrix, right? We multiply by each term. So 3 would multiply by 3, and 3 would multiply by 5, and you'll get 9 over 15. It's the same thing for vectors. So -1 AB with -1 by 4 over 6. And we say we multiplying, oops, wrong color. We multiplying the 1, the -1 by both terms. Right? So be -1 by 4 over -1 by -6. And -1 by 4 is -4, and negative by a negative is a positive. 1 by 6 is 6. Right? So negative AB, oops, is -4, 6. Now, if we were to draw this on a graph, right, and I started here as A, and B is to the right 4 times, or 4 spaces, and then down 6, 1, 2, 3, 4, 5, 6. To B, this vector here, right, was 4, -6. Now this vector, right, that we have -1 AB is -4, -6. So we're going this way, 1, 2, 3, 4, and going up 6 spaces, 2, 3, 4, 5, 6. So we end up back at the same place, right? So what this really means is that what? We just change the direction of the line. So instead of going from A to B, this is really B to A. So that is how we have the negative, sorry, I write it wrong. Still writing it wrong. Right. Negative AB vector. And that's from this rule here. So if the vector change direction, all we do is multiply the vector by -1. So another example of that, if PQ is equal to -3, -5, what is QP? What is the vector QP? If we watch the letters PQ and then QP, all we're doing is putting a negative sign in front of the PQ. So negative, -3, -5, and then we would multiply. Anytime we do have a number, we understand the number to be 1. And then we will multiply. -1 by -3 is +3. -1 by -5 is +5. So the change of direction would be +3 and +5. Right? So that's how we change the direction. Right. So the triangle and this is from the notes that we did before, just in case those are probably coming late. The triangle law for vectors. If two vectors, and I have it here, I'll pull it up to give you the correct word. Two vectors represent two sides of a triangle with the order of the magnitude and direction. Then the third side represents the magnitude. Right? That's too hard for me to remember. Right? If two vectors represent two sides of a triangle, then the sum of the two vectors will equal the vector of third side. Basically, that's what they're saying. So if you have two vectors, right, and remember, vector goes from one point on X, A to B, B to C, right? The third vector, or the third side in the triangle, sorry, will be equal to the vector AB plus BC, right? And this will be called AC. So if we have an example again, 3, 5, 7, 8, 9. Right, so again, if you were to sketch this starting from A, 3, 5. So 3 is the X, you'll go across 3 units on the graph, and 5 will be 5 and positive, so it'll be going up 5 units to B. And from B to C, it's 4, -2, so we're going 4 units on the graph this way, and then down. So C, So you have this vector here, and this vector here. Here will be the vector AB, and here will be the vector BC, right? The resultant vector from A to C would be AC is equal to AB plus BC, right? So AC equal AB plus BC. So 3, 5. Anybody want to talk and help me write it out? 4 over -2. And we add in like matrices style. What will be the vector here?
7.
Alright, well 7. So 3 plus 4, 5 plus -2. And then we have
2.
two signs to each other.
Yeah.
A bracket, right? So 7 and 5. This here will result
Plus
in what
M3.
sign? A subtract, right? So 5 take away 2 is 3. So AC will be 5, 3. Right? Then we have the parallelogram law. And I have this one here and also. If two vectors act simultaneously on a point, the resultant vector can be found by oops. Right? So again, what does this mean? If we have a graph and that line to tick, right? So if you have one going this way, and you have one going this way, and they acting on the same point, so A to B to C, you have AB and AC. We could complete a parallelogram to get the resultant vector. This will be the resultant vector we're looking for. Let's call this point D, right? So here's AB, here's AC, here will be AC, and here will be AB. Why did I label this here as AB? Why did I label here as AC? What do we know about a parallelogram? Anybody?
So because the sides equal.
The opposite sides are equal, very good. So this side here will be equal to this side here. This side here will be equal to this side here, right? So the resultant vector AD will be equal plus AC, or we could write it in the other terms if we are given the other side. So if we have BD, add C to D. Ooh. BD, let's see, yeah. Right. Now we'll also give it time running out. I want to take rule. I will put everything up on the YouTube channel. Right, this is only notes in parallelogram, in vectors. Right, we did a couple questions and stuff on this. This is just a review, and this is the last of the review, and this is all we did. We did for the term. So I could go forward with the next one, which is translation, rotation, reflection. You all would need graph paper for the next class, I believe.
Good. We finished translations. And what's up already? Or
No,
that
we
is up.
didn't start that as yet. That's the next thing.
Okay.
That's the next thing to finish. Right? So yeah, this is all your notes here. Let me take a roll quick.